Welcome to The Explainer. Today, we're diving into something pretty cool, how the virtual world is stepping in to solve some very real, very big challenges in one of our most important industries, wind energy. You'll see it's a story about tech, yeah, but it's really about building a skilled workforce for a much more sustainable future.
All right, so let's jump right in. To really get why this immersive tech is such a big deal, you first have to understand the massive scale of the challenge that the wind industry is staring down right now.
And seriously, think about that for a second. This isn't just some hypothetical question. It is the central, practical problem that's creating a huge bottleneck for the entire wind power sector. And the answer? Well, it's not as simple as you might think.
You see, as we all push for more renewable energy, the demand for wind farms is just exploding. And every single time a new turbine goes up, the demand for people to build them, operate them, and maintain them grows right along with it. We are talking about hundreds of thousands of new jobs.
But here's the thing, we don't just need more people. We need highly skilled people. And our traditional ways of training them, which can be super expensive, kind of dangerous, and definitely slow, just can't keep up. This skills gap, it's a major roadblock to our green energy goals.
So how in the world do you bridge a gap that big? Well, the answer might just be to build a perfect digital mirror of our industrial world. Yeah, this is a term you'll hear from big names like Siemens and NVIDIA. And listen, this has nothing to do with social media or video games. It's about creating this shared digital space where we can design, test, and train on incredibly complex machinery in a virtual world before anyone even picks up a real wrench.
This slide is actually a great way to think about it. This whole shift is a lot like how we all moved from old-school analog film to digital cameras. We're basically taking the physical world with all its nuts and bolts and turning it into digital data that can be copied, shared, and messed with from anywhere on the planet. Okay, so this industrial metaverse isn't just one single thing. It's built on a whole bunch of different technologies that, let's be honest, people often mix up. So let's just take a second and break down the key terms so we know what we're really talking about.
The best way to think about it is on a spectrum. On one end, you've got the real physical world that we're all in right now. On the total opposite end, you've got virtual reality, VR, where you put on a headset and it completely blocks out the real world and plunges you into a digital one. Now, the space in between, that's where things get really interesting. You know, the easiest example of augmented reality, or AR, is probably a game you've played, Pokemon Go. You're looking at the real world through your phone, right? But digital stuff, like a little Pikachu, is layered right on top of it. You are literally augmenting your reality. Okay, so we've got the problem, this huge skills gap, and we've got the tools, VR and AR. Now for the fun part. Let's look at how this technology is actually being used right now to solve that big training problem.
This quote right here, it just hits the nail on the head. It perfectly shows the core issue. Even the professors and the experts can't always get direct, hands-on access to these machines. So if they can't even get inside, how are we supposed to effectively train a whole new generation of technicians?
For education, this stuff is a total game changer. It makes the inaccessible accessible. Imagine giving students virtual field trips deep inside a turbine to sell, or helping an engineer who's never been near one finally grasp the true, massive scale of the components. You can simulate what it's like to work in those tight, awkward spaces, all without anyone leaving the classroom.
And for the actual technicians, the benefits are even more immediate. Think about it. They can practice a really complex repair over and over and over again in a totally safe digital world where nothing can break. They can run through emergency drills you could never simulate in real life. And with AR, they could have a digital manual or instructions just floating in the air, right on top of the equipment they're fixing.
So what's the ultimate impact of all this? You know, what really happens when you bring these incredible digital tools into the very, very physical world of wind energy?
Well, this slide gets right to the heart of it. Get this. Research shows that a huge chunk, we're talking 30 to 40%, of wind turbine failures are because of human error. That is a massive problem that better, more realistic, and endlessly repeatable training can directly fix, which makes the whole system much more reliable.
And the potential here is just enormous. It's estimated that a full 60%, more than half of all jobs in the offshore wind industry, could be made better with these immersive technologies. And that's not just the technicians climbing the towers. We're talking about designers, quality control, safety officers, you name it. So what you end up with is this incredible positive feedback loop. You start with accessible, really realistic training. That leads to fewer mistakes, so you get reduced human error.
That, in turn, boosts safety and the quality of the work. And all of that comes together to build the sustainable, highly skilled workforce the industry has to meet our energy needs.
And that really brings us to the biggest takeaway of all. Using this tech for wind energy, it's really just the beginning. It's a blueprint. It's paving the way for a whole new era of training in any complex, high-stakes job you can think of, from surgery to aviation. So the question isn't if this is going to change the way we work, but how fast it's going to happen.